Welcome to the presentation.
I
I
am
am
Harish,
Harish
and
and
uh,
Hi,
hi,
this
this
is
is
Ram
Ram
Shakthi.
Shakthi.
And this is Vignesh.
and we
And
are
we
going
are
to
going
be
to be
discussing
discussing
about
about
closed
closed
loop
loop
control
control
of
of
DC to
DC to
DC
DC
buck
buck
converter.
converter.
Moving to
Moving
the
to the
outline of
outline
the
of the
presentation,
presentation,
we are
we
going
are
to
going
be
to be
discussing
discussing
about
about
the
the
project
project
source,
source,
the
the
converter
converter
topology,
topology,
the
the
control
control
objectives,
objectives,
the
the
control
control
methodology,
methodology,
code
code
generation
generation
model,
model,
and
and
then
then
finally we
finally
are
we
going
are
to
going to
summarize the
summarize the
whole
whole
presentation.
presentation.
Looking at
Looking
the
at the
project
project
source,
source,
for
for
your
your
reference,
reference,
we would
we would
like to
like to
tell
tell
you
you
that
that
we
we
have
have
chosen
chosen
project
project
number
number
10 in
10
the
in the
list,
list,
and the
and the
title of
title
our
of our
project
project
is
is
Closed
Closed
Loop
Loop
Control
Control
of
of
DC to
DC to
DC
DC
buck
buck
converter.
converter.
There
There
weren't
weren't
any
any
link to
link to
YouTube
YouTube
videos
videos in our
in
in the
the
in the
list for
list
the
for the
project,
project,
but
but
we
we
did
did
have
have
Matworks
MathWorks
link
link
to
to
the
the
source
source
files and
files
the
and the
design
design
files for
files
the
for the
project.
project.
Now,
Now,
the
the
reason why
reason
we
why we
selected the
selected the
project
project
is
is
that
that
we
we
selected the
selected the
project due
project
to
due to
its
its
relevance in
relevance in
power
power
electronics,
electronics,
practical
practical
application in
application in
various
various
industries,
industries,
and the
and the
opportunity to
opportunity to
gain
gain
comprehensive
comprehensive
knowledge
knowledge
about the
about the
control
control
systems
systems
used in
used
the
in the
project.
project.
This
This
project
project
offers
offers
valuable
valuable
insights
insights
into
into
optimizing
optimizing
power
power
conversion
conversion
efficiency,
efficiency,
understanding
understanding
voltage
voltage
feedback
feedback
loops,
loops,
and
and
exploring
exploring
advanced
advanced
control
control
algorithms,
algorithms,
contributing to
contributing to
academic
academic
and
and
professional
professional
growth in
growth
the
in the
electrical
electrical
engineering.
engineering.
And
And
now,
now,
Ram
Ram
Shakti will
Shakti will
take
take
over to
over to
discuss
discuss
about the
about the
converter
converter
topology
topology
of the
of the
project.
project.
In
In
this
this
slide,
slide,
you
you
could
could
clearly
clearly
see
see
the
the
circuit
circuit
diagram
diagram
of a
of a
simple
simple
buck
buck
converter.
converter.
In the
In the
left
left
side
side
of
of
the
the
slide,
slide,
you
you
could
could
clearly
clearly
see
see
the
the
voltage
voltage
source.
source.
And
And
moving to
moving
the
to the
switching
switching
device, we
device, we
can
can
use
use
various
various
type
type
of
of
power
power
transistors
transistors
like
like
IGBT
IGBT
MOSFETs,
MOSFETs,
and
and
it
it
depends on
depends
the
on the
power
power
rating
rating
with
with
which we
which
are
we are
working
working
for.
for.
So
So
there are
there are
wide
wide
range
range
of
of
power
power
ranges and
ranges and
voltage
voltage
ranges
ranges
which
which
can
can
be
be
utilized
utilized
or
or
which can
which
be
can be
made
made
use
use
of.
of.
So
So
depending on
depending on
our
our
needs,
needs,
we
we
need to
need to
select the
select the
device
device
according to
according
it.
to it.
So
So
similarly,
similarly,
that
that
applies
applies
the
the
same
same
for
for
the
the
diode.
diode.
Based on
Based
the
on the
power
power
requirements, we also need to select the diode. So this inductor that is provided here is to minimize the current ripple, the current ripple of the supply that we are generating, and the capacitor that is always connected across the load in parallel to the load, actually in parallel to the load. So it will minimize the voltage ripple of the waveform that we are providing. Actually, this buck is a simple SMPS. SMPS stands for switch mode power supply, in which DC supply is actually switch on and off at a high frequency. So we get an average of what at the end of the terminal at the load actually. So during the on state period, in the next slide you could clearly see that during the on state, um, the source is directly connected to the load through the inductor. So during this period, the voltage would be equal to that of the input voltage. So during the off state of the power switching devices, so this diode acts as a feedback loop through which the power that is stored inside the inductor gets the energy, actually the energy that is getting stored in the inductor will get transformed through the diode uh, to the load actually. So in this slide, you could clearly see the waveforms. So the first waveform is the input that is maintained constant. Actually, in the practical situation, this might not be constant. That's why we are getting involved in closed loop control. In practically, the output current, which means the load, might need various current loads. So when we consider a motor, when there is a higher torque required, the motor pulls a lot of amount of current. So due to this load variation, there might be a change, right? So to prevent the change in the voltage that we are maintaining, so we go for a closed loop. So next waveform, you could clearly see the on off. During the on time period, the output voltage will be equal to the input. During off, it will be equal to zero. So the diode current during that period will be rising and falling like a trapezoidal waveform. Similarly, the I naught current, the output current that is flowing through the load will be of this kind of waveform. In the next slide, we will be seeing about the control objective. Why are we going for a control? Can you go for the next slide? Okay. This slide, the objective is very clear, stating that we need to maintain the output voltage and the inductor current, which means the output current. But why are we going to this controllers? There will be a very varying input supply as well as the load may be varying. So to prevent this, to prevent our output voltage to be to vary, not to vary, we go for a closed loop control. So this closed loop control, we are taking the sample from the output voltage actually, and feeding it into a microcontroller, so which compares the error signal produced by comparing the output voltage with the reference signal, and this error voltage is again fed back to the gate signal of the switching devices as a pulse width modulated signal. So this pulse width modulated signal, you could clearly see in the next slide. We have actually used the F28379D microcontroller. It's a C2000 family controller, which we have used in our modeling, MATLAB modeling as well. So this control uses an ADC through which the output voltage is sampled and given to the microcontroller, which is actually compared with the reference signal, and error signal is produced. So based upon the reference signal and input of the output voltage, it produces an duty cycle which is fed back again into the switching mode. So it varies the on and off time of the wave, the device, switching device, in order to maintain the output voltage constant. That's what the main motive of. So in the next slide, you will be seeing about the control methodologies with which Harish will be explaining.
Now we are going to look at the control methodology of the controller. The controller, which is implemented with the C2000 microcontroller, continuously monitors the output voltage using an analog to digital converter. The analog to digital converter calculates the error signal by comparing the measured voltage and with the reference voltage. Now, in this system, we use a control algorithm such as PI. We could also use PID, but PID controllers amplifies the noise in the electrical system, which is why we use PI generally for most of the electrical systems. Using PI control algorithm, the controller adjusts the duty cycle of the power with modulation signal using the EPWM module. This controls the switching of the buck converter's power switches, ensuring stable output voltage regulation. The C2000 microcontroller provides the necessary computational power and peripherals for efficient control algorithm execution, enabling precise and reliable regulation for the DC to DC buck converter. Now we are going to look at the design equations of the converter. So there are 4 design equations for the converter. Looking into each one of them, the first one is calculating the duty cycle. The duty cycle can be calculated as the ratio of output voltage to the ratio of input voltage. Moving to the next equation, which is the inductor current ripple. The inductor current ripple can be calculated, the difference in the inverter current ripple can be calculated as input voltage minus output voltage into the duty cycle divided by frequency, and it can divided by frequency into the inductance of the systems. And the third equation is the output capacitor, which calculates the capacitance of the capacitor, which is equal to input current ripple into the difference in the time period divided by difference in the voltage. And the last equation is switching frequency, which is equals to the input voltage minus output voltage divided by the inductance and the higher maximum inductor current ripple in the circuit. These design equations help us determine the duty cycle, inductor current ripple, and the output capacitor value and the switching frequency for the DC to DC buck converter, which helps us to design the system in a stable way. These are essential for the proper design and the operation of the converter. And now, Vignesh will be taking over to discuss the code generation module for the converter.
So now on coming to the code generation model, we are for the from the reference model which we got, we are having a DC to DC synchronous buck converter with average current control mode using CLA. So with this module, we are having an PA controller, a code generation module, and as we are using a C2000 microcontroller, all these EPW modules ADC comes inside the C2000 microcontroller. So we are modifying those EPW modules and ADC modules. So we are modifying that EPW modules to with the counting mode of up down mode. So after changing that, we are changing this CLA control accelerator, which is present over there in the C2000 microcontroller, which acts as an algorithm for the PA controller. So we are making this control accelerator to be a read-write module, which helps us changing the proportional and integral parts of the PA controller algorithm and getting the efficient output for the closed loop system. So after this, we would summarize that from this example of a closed loop control system using a C2000 microcontroller for a buck converter, we have implemented this with the help of MATLAB as well as the embedded coder support given by Texas Instruments. This project aims to optimize power conversion efficiency and achieve precise voltage regulation, which is an intrinsic property which can be exhibited by a closed loop control system. So and also explores advanced control algorithms. So the controller continuously monitors the output voltage and generates an error signal, adjusts the duty cycle, and provides a pulse width modulated signal to as a duty cycle varied signal to the switching device, and controls the buck converter power switches. The microcontroller, along with this MATLAB and embedded coder support provided by Texas Instruments, provides a comprehensive platform for designing and implementing the control system. Through this project, myself and my friends have gained some knowledge in power electronics, control systems, and microcontroller based algorithms. We have the references provided in the PPT at the last. So thank you. Thank you, sir, for giving this opportunity.
Thank you, sir.
Thank you.